So here we are going to implement this circuit with Tinkercad. This circuit is basically a parallel RLC circuit with supply as sinusoidal supply. So let's move forward and open the Tinkercad website, and let's also log into that. So I've already logged into my Tinkercad account. Now I'll click on this create button. Then I'll click on the circuit button. Once I have clicked on this circuit option, I'll be moved towards a new window. Here in this window we will be creating our circuit, and which can then be simulated. Also on the right hand side you can see the possible libraries option, where the possible elements which we can use are provided. So using this search bar we will type the name of the element which we will require according to our circuit. So let's have a look on our circuit to check on the elements. Here we can see this is an RLC circuit, so we will require a resistor, inductor and a capacitor. Also we can see the supply is a sinusoidal supply, if we will require a sinusoidal source. So for the sinusoidal source we'll make a search of function generator in the search bar. So we can see the function generator is appearing over here. What we will do, we will click on that and drag that into our window. Unfortunately I clicked on that 2 times, that's why it's appearing twice. What I'll do, I'll click on that and then select the delete button, so it's not deleted. So now I'll move on naming this function generator. You can name it as you like, but I'm going to name it as just AC source. And because the values were not given in the question, so I can just assume the general frequency as 60 Hertz and amplitude, let's just leave it like that. DC offset, yeah, because this is a pure sinusoidal supply, so DC offset is 0, and the source is sine, so sinusoidal source will be selected over here. Other options are also there like a square and triangular, but just sine will be perfect for us. So as per question, we have to implement this RLC circuit using a breadboard. So what I'll do, I will search for the breadboard and let's see. Yeah, let's see the possible options which we are getting. So here we can see 3 types of different breadboard options. I'll select this one. So the first one, I'll click on that and just simply drag that. Yeah, here it's up. So for now I'm just naming it as breadboard. So similarly I will make a search of resistor, capacitor and inductor and will simply drag them into our working window. Now before moving any forward and making the connections on the breadboard, I will first explain some of the basics of the breadboard, which I think would be necessary for to avoid any sort of confusion. So over here, as you can see, the voltage across these pins will be same. Similarly, the voltage across these pins will also be same. But the voltage across these 2 pins will depend on the supply that will be connected. Over here, the positive or the negative is mentioned, if you notice that. So this positive and negative means like just for our reference, it's nothing to do with the inline circuit, so it's just for the reference. So better we will connect the positive terminal of the supply with this. Similarly, the voltage across these points like this, they will be same, and just like I have shown you above. So like the voltage is same for all of these points. So one more thing is needed to be noticed is that voltage across these 2 points will never be same. So voltage these 2 points will not be same. If you connect if you connect the same voltages to these points, then only the voltage will be same. Otherwise there are no other possible options like that. So I hope this much of the basics will be enough. So now let's continue. Now one more thing I want you to understand is that if we connect any element, supposedly I connect a resistor like that, then in that case it will be shorted, because I already told you the voltage across these points are same. So in case if you connect any element like that amongst the same, that means the 2 terminals are having the same potential, so in that case it will be shorted and it will not work. So instead of connecting like this, we will rotate the element and make the connection like this. So now we are going to connect the input voltage supply with our breadboard. So for that we will use the normal wire. There are other possible options, but for our case we will just use a simple normal connection of the wire. So we will just simply click on that and then drag that, and we'll connect to the positive terminal, or where the positive thing is mentioned in our breadboard, just for better reference. Similarly we will do for the negative terminal also, and we'll connect like that. For the parallel RLC circuit connection, I have dragged the inductor, and now I'm dragging the resistor just under that, and finally the capacitor. So now I have placed the capacitor in the other circuit for making you understand like how are we going to make the connection with this circuit as well. Now we want the voltages across these terminals to be same because this is a condition for the parallel circuit. So for that we will be placing them in a row just for our understanding, and we want the voltage across these pins to be same, so we are shorting these two pins as you can see. So now the voltage across that will be same, and now I am going to short the other pins so that the voltage across the other pin of the capacitor, inductor and the resistor would be same, just like that as you can see. So just a simple wire would be good for us, and now we are going to connect the supply. So for connecting the supply with the pins in our breadboard, what we are going to do, we are going to connect the parallelly connected nodes of the RLC circuit in a way that one is connected to the positive terminal. So for that I am just going to short these two pins, and for the negative connection I am just going to short the other pins. We will be connecting the positive terminal video. I think with the positive it would be easy for you to understand. It's a simple connection. Just apply the basics of the breadboard as I have already discussed with you. So now we have already connected the circuit, and our circuit is ready to go for the simulation. Since there are no values given, only the implementation was needed to be done, so I have done that. I hope the simplest implementation of the RLC circuit was easy for you to understand, and in case you want me to simulate using the values, you can please drop those values in the comment section. I'll try to make that video, and in case you have any doubt, please reach out to me to my comment section. Also please don't forget to subscribe. Thank you.